Okay, so I'm giving a talk on AI, and I've always wanted to like spread the word about this. This is from an episode of Star Trek: The Next Generation, and keep in mind this clip is about 37 years old.
Yeah, ordinary.
Oh no, the audio is not great.
We'll say listed. Tell.
All right, I'll just give the synopsis. She says please and thank you to the computer when she's ordering her hot chocolate. And Jordy makes fun of her, and he says, you know, why do you say please and thank you? And she says that I'm in this habit so that I don't forget about my humanity, because if I mistreat the computer, that may translate into mistreating other humans or other people. So that's kind of just my little weird moral thing for the day. Let's get started. So my name is Isaac. I am author of the Ziegler library, which is a NIF library, and I call myself an ex-Elixirist, but we're probably going to find out that I'm not really an ex-Elixirist. You can never really leave. So I'm leaving tech to start my own company. Vidala Labs is a pharmaceutical company. We'll be working towards making important life-saving drugs much cheaper, like let's say more than 10x cheaper, which will improve access around the world. So that's the mission of Vidala Labs. But enough about that. We're here to talk about Elixir and AI. And we're going to go down this list of galaxy brain stuff, brain evolution. So who here doesn't use AI in their workflow? Okay, so actually like a few people. And if you don't, maybe this will like convince you to take a look at it. Or maybe it'll make you scared. I don't know what's going to happen. But so we're going to just jump into some demos. The first demo is called Techo. I built this for a friend. It's a roof simulator software as a service, basic Elixir Phoenix Star app. The original author used Replit and made a non-deployable version, and so he asked me, hey, please make this so that I can deploy it. Read it in Elixir. Claude completed this in about 3 working days. That's probably about like 9 hours of me going. And so basically, the workflow is you sign in. Let's continue with Google. So it's got proper auth. We're not going to, oh, no. Oh, shoot. All right. I'll just tell you how it works, because this is going to take too long. That goes to show you should test these out first before you're doing a demo. But anyways, what it does is you can take a picture, and if you want to see this later, I can show you in person. You take a picture of your house with a roof, and you tell it, hey, like I want a roof with like orange tiles instead of what I got now, and it will render a picture of your house with those roof tiles using, actually not even really rendering, but like it's a simulation, if you will, via ChatGPT's like image generation app, and it's extremely faithful. There's a couple of things that still need to be worked out, but it's a great tool, and my collaborator has already made like a $50,000 roof sale off of this. So it's nice, right? Like if you've ever had to buy a roof, you kind of are in this place where like, I'm not sure what it's going to look like. And this will help assuage your fears. Second demo is called BoxFan. And as I said, I'm starting a pharma company, right? And one of the guiding principles of the pharma company is to just have 100% in-house software. If you've ever worked with scientific equipment, the software layer is atrocious. And also, it's very hard to get interop. So building an in-house like stack that like acts as a layer to unify everything is going to afford huge like efficiencies in the process. And that's important if we're going to deliver something at a much lower cost. So this is a Nerves app, and I actually don't have a ton of experience doing Nerves. Claude completed this in one working day. So that was about maybe 6 hours of me actually like twiddling with it. And this is also like a long festering side project. So I'd been meaning to do something like this. I repurposed some hardware that I had for like cleaning up the cooking air. And I'm going to describe what exactly this does in a moment. But it had been sitting in my room for 2 years because I was just like, oh, I don't know if I want to like dive into Nerves to get this done. And then it was done in one day with help of Claude. So what this is in my garage, I have a bio lab. That's that thing in the green. This is what it looks like from the outside as it was under construction. And so the whole thing is like enclosed in plastic. And kind of on the inside here, there's just a filter, and then there's a fan that pulls outside air, recirculates it in, so that if I'm working in there, I'm not going to suffocate, and any of the microbes that I'm working with will have a fresh dose of oxygen every so often. So let's take a look. So this is live over Tailscale. So Claude built this graph from scratch using SVG, right? So this is the temperature. Humidity looks like this. You can see the yellow bars are when the fan has been turned on and off. And then you can see that it equilibrates. And there's also a manual fan control. And the other thing about this device is you can also manually control it, although it won't be tracked. And we have like a list of events. This is all built off of Tailscale, which I didn't know how to use that with Nerves. Ecto SQLite, and just this like I2C thing, or I squared C. See, I don't even know the right terms, but it's live. I just turned it on, and you can see it logged that it got activated there. Okay, and it keeps track of all these things. And this for me is a great proof of concept, right? Like this idea of being able to take a lab and have everything be unified in with all the data ingestion into one stream, eminently doable. So, on this tweet, everybody should vibe code an app to see two things: how insanely powerful LLMs. I mean, if you don't believe me that this is doable in one day, it's doable in one day. But you should also know the specific ways in which they suck. And for example, in this particular project, it was terrible at stapling Phoenix onto Nerves. And I'd forgotten that Hello Phoenix in the Nerves toolkit existed, right? It is really good at chasing down bugs. So even though it was terrible at stapling these things two together, one of the problems I ran into was that Phoenix was binding to 127.0.0.1, which meant that I couldn't see it anywhere else on the network. And it was pretty quick to say, hey, you need to bind that to 0.0.0.0, right? And figuring out the right set of prompts to feed it is key. And I don't see him, but anyways, Thomas Miller basically was the one who keyed me into this. And one of the tricks is to say, hey, Claude, what would you have done wrong? What could I have told you to get you to not make this mistake? And then feeding that back into the loop and putting that back into the prompt is like a way to sort of like really asymptotically improve the way that Claude codes. A human in the loop is still necessary. You need somebody who has experience to be able to look at the changes that go through and say, reject this change, which is maybe about like 1/5 of the time, but it's still necessary. So that was level 0, just like building an app. Everybody's going to be doing this. But what I'm also interested in is what are ways that we can contribute back to Elixir using AI. And so a little bit more big-brained is build a foundation library with AI. So the example I'm going to give you is a library that I built over a few months. I think this will probably be faster now because AI has really improved even in the last 3 months. I also started with Phoenix New and then migrated to Claude. And so what VSR is the distributed consensus protocol, right? And so what I mean by foundation library is like a library like rec or something that's really core. You don't want to have AI have to rewrite it over and over every time, which is something I'll talk about in a bit. But like, something that is missing from the Elixir ecosystem. And so, in fact, I don't think we have a really good native consensus protocol. For reasons VSR is kind of forgotten, it was invented by Barbara Liskov, and you should think of it as like a better version of Raft. There are problems with Raft that don't exist in VSR. And this is now it's a pure Elixir library, and I went through several architectural refactorings. We're going to do a quick demo here. And the key is that Jepsen, which is the company that reviews like all this distributed database stuff, and they like, tear into like all these like, I think the famous one is MongoDB. I think they tore into MongoDB and said, you guys are like, are crazy. So they provide something called Maelstrom, which is an open source Java / Scala package you can do to test your distributed consensus systems. So this Elixir VSR library not only can do things across the Beam cluster, it has like a different plugin that you can switch in for Maelstrom's way of managing a cluster. And so what Maelstrom here is going to do is it is going to build a cluster of three instances of VSR on the system, and it's going to manage the network. And it'll tear down and bring up like nodes, and you can validate that, hey, like the distributed consensus is correct. And so here you can see it produced a report. Everything looks good, even though it was, and you can actually look at the individual. So here it's doing a read from like position 0, and then it got back nil. And so it goes through and checks the log of all of the things that it did and makes sure that, hey, is this actually what it should be? So the nice thing in this case is for a foundational library, one thing you might want to have is a very strong set of like automated tests to validate that what you're producing is good, especially if you're giving it back to the community. So going from this, I want to talk about the title of the talk, which is Getting Elixir on the AI Flywheel. And the background of this is there's this computing flywheel that we've been experiencing for the last 40 years, right? We start by building a computer. Now we can write software. The software will lead us to better EDA tools. And with better EDA tools, we can build better computers. And then we can build better software on top of that. And then build better EDA tools. So this flywheel starts charging itself up. And I think that there's a similar flywheel with AI. So let's start like charging in that direction. So one thing you can do is to build an AI tool library with AI. So in this case, something that I built over the course of 1 week with Claude prompting was an Elixir MCP. So if you don't know what an MCP is, this is basically a plugin that AIs can access and say, hey, like, tell me something that I don't want to have to like figure out for myself. So a good analogy is like for a human, if you don't want to do like routine math, you can use a calculator. Well, an MCP is sort of a shortcut path that like lets the AI, do something that is already is mechanical and effectively, or possibly like a second brain. This took about like 1 week of Claude prompting. I had cloned Tidewave and GraphSense. So Tidewave is the official, semi-official Elixir MCP that gives you a lot of information about like your code base. And GraphSense is this one that I found on TypeScript and JavaScript, which builds up a graph of your code, so what functions call what. And it also does, it's a RAG, so you can read code, and then it'll save it into a database with like a vector search algorithm. So you can kind of do like, hey, tell me about like which functions look like their database calls, for example, right? Demo here. So I'm going to run Claude in the Techo repository. And so, OK, so now it's asking me for permission. Sorry, this is small. It's asking me for permission to use the list function callers tool that was provided by Codicil. And it found 5 callers here. And here you can see the list of all the functions that call data.repo.get. Right? So it didn't have to search through the database and find all those function calls. And also in Elixir, if you are using libraries that are maybe clever, those might be hidden in the code. You wouldn't know. But so if you're just scanning, like grabbing through files, you might not be able to know every single function that calls a function like data.repo.get, right? But what Codicil does is it reads your bytecode, so it knows for sure that this has been called, even if it's been hidden by macros. Okay. So fortunately, it works. This is great. Like the whole Claude was able to figure out how to parse decompiled Beam bytecode with like 0 shot. I didn't have to like send it to any documentation. I was dumbfounded. However, like I'm finding that like convincing the LM to actually use the MCP is a little bit challenging. So there's probably a little bit more work to do this. If you can figure this out, Codicil is available on hex.pm. So if you want to play around with it and let me know what I can do to make that better, please join the Flywheel. So now I'm going to go into like speculation mode. So why are AIs good at Elixir? I think there's like a few like really superficial reasons why Elixir is like actually a fantastic language for. And by the way, like I see on like social media feeds like Twitter, like people complaining, oh, like AIs are terrible at coding Rust, or AIs are not good at like TypeScript. Apparently AIs are better at JavaScript than TypeScript. Crazy, right? But OK, so Elixir specifically, file paths usually match module names, right? This is not the case in JavaScript. This is not the case in Python. There's like weird indirection that happens. And I say usually, that's also not the case in Phoenix, right? Imports in Elixir are kind of like frowned upon in the community, not totally frowned upon, but especially like unqualified imports, where you don't do import blah, comma, list of functions that I'm importing, right? We really try not to do that much. And finally, like passing a term can't change it. So you're not gonna, some junior is not gonna write a function that's like 8 calls deep that's gonna modify your dict. That's not a thing in Elixir. So the LLM can reason through the code path of a function and know what's going on with like high confidence, right? So I have a few like weird guidelines that I do that like improve LLM competency Elixir. I have no evidence for this batch here. So avoid alias AB. See, that's hard to grep and replace, and like a lot of the code editing tools that AIs use is grep and replace, so don't do that. And also, I mean, this is fine for IEX, right? And I tell them if you ever use IEX, please feel free to like use that format. Avoid imports, as I said, and I go further. Like I tell the LLMs don't import ecto.changeset, right? Don't use macros to save on typing. Typing doesn't cost you anything anymore. And you got to be vigilant about conventions, and I try to avoid libraries that don't follow the conventions. In fact, I try to avoid libraries now. And then instruct the LLM to use TDD, right? Like, I mean, TDD is like out of favor. I think it's going to come back in favor because LLMs, like, if you tell them to do TDD, they'll do it, and it makes your life easier. OK, so this is maybe more hot takes here. So I have a package called Phoenix that's simple that I clone, and it has a different hierarchical layout relative to what you might be used to in Phoenix. So I have a bunch of top-level namespaces, data, web, auth. I'm not publishing a library. You guys don't have to use like my own private like app that I'm deploying. I can use whatever namespace I want, right? and there's not going to be a collision. I don't use the myapp-web macros. The web directories are organized by context and not functional type. That makes your module names match your paths, which makes the LLM search easier, and it makes the LLM have to reason about less and uses less tokens. This is a weird one. I have no evidence for. Condu. I do this weird thing with cons where I instead of doing true, because like it's confusing. You get like true gives to, and sometimes it's like you'll see like true arrow false. And like, I mean, that confuses me. So I think the LLMs probably stumble on it a little bit. Again, no evidence for this, but this is what I do. And I will say you often don't need to use a library. So I didn't get to demo Techo, but like, you know, all of the ChatGPT calls are just written through rec, right? So that's being the difference. So you maybe don't need to have API libraries anymore, right? You can just issue a rec statement. The AIs know how to do that, right? Foundational stuff, clearly more important. You will probably need libraries for those sorts of things. And then this is a shameless plug. I actually have evidence for this. So I wrote a library called Protos, which rewrites your protocols. And just if you look at the bottom here, this is what it looks like. So you create a protocol with use Protos, and in your struct modules, you can use proto, and that creates a def delegate. I know def delegated are considered harmful, but it delegates all of the protocol. It delegates your protocol implementation back into the parent module. And really, like, the biggest thing is that you get direct access to private struct module functions. Like, you don't have to this def p private thing that you might be like a utility function for your struct. You don't have to def that so that the freaking, like, you know, so that the freaking implementation has access to it. You don't have to do that anymore, right? And otherwise, it doesn't really disrupt how you do protocols at all. So it's a very minor change to the language that's backwards compatible. And I find that LLMs, when I don't use Protos, like LLMs will really just start trying to do things as if Protos existed. And then you have to stop and correct them and say, don't do this. And the reason why I think this happens is because there's like a natural mapping from object-oriented programming to the way that you want to do function layout, which is driven by the fact that like Elixir has a first term like convention that, you know, the first term is supposed to be the whatever you're talking about in the module, right? So, so I think the LLMs still get a little bit confused because of their overlayering of OOP stuff. Okay, you can do that. Okay, so I still think though it's really unreasonable that AIs are so good at Elixir because we're like a niche programming language, right? And so maybe part of it is that Elixir is LLM friendly in the ways that I talked about before. I think maybe also another factor is that Elixir coders are usually senior devs, so the sources that it can read on the internet are really high quality. I think that helps. But really, like the hot one is this paper that came out by Anthropic that it only takes 250 documents to poison a data set. So like, let's say you have like a, you know, Joe's like auto shop in Houston, Texas. And you're like, okay, I want the LLMs to like drive customers to this. You only need to make 250 documents. So spin up a GitHub repo and like make 250 things that say Joe's like tire shop. But so, you know, in a weird nominative determinism, where Elixir is something you give to somebody that's like a poison, but it makes them better, right? Usually. And so, like, you know, we were kind of positively poisoning LLMs, a weird nominative determinism. I guess Jose was a genius or something. But here's the danger. If AI companies try to mitigate poisoning, then Elixir risks losing its disproportionate competency. I'm not saying this is going to happen, but it might. So the last like brain size is to build AI libraries with AI. And this is, you know, what if AI companies start to mitigate poisoning and we lose it, right? We could lose our competency, we could fly out, we could be ejected from this flywheel. And you know, I'm a little bit selfish here because like wanting to start a pharma company, you know, I want an on-prem AI that never sees the internet. And also like, you know, the commercial AI stuff is now actively blocking innocent biotech stuff, right? Like, so if I ask how do I make LB media, which is a common media that you learn as an undergrad how to make, it says, sorry, I can't answer that, it breaks my guidelines, right? Now, you can buy your way out of that. I think they have on offer these solutions where it's less restricted in those sorts of things. But I don't want to have to rely on that. I don't want to have to rely on that. So I want like an AI that I can have on-prem that can code Elixir and also do biotech, right? So the pipeline that I want to see, and you know, I don't know if I'm going to build this or somebody else wants to help me building this or if it'll ever get done. But this is what I imagine would be great. Sort of a state-of-the-art model plus data set. We don't need to train it for now. We'll figure that out later. A way to augment it with Elixir examples. A procedure for structurally tuning the LLM. So that means like making Elixir keywords first-class tokens in the LLM. Being able to fine-tune it. So there's a Python program called Unsloth, which will let you fine-tune models and give it more examples without having to do the full training all over the from scratch. So that would be nice to have in Elixir. And you know, a way to sort of build a quantitative quality score for all these. You know, is it good at programming Elixir? Does it give reasonable responses for, you know, just general queries? What's the capital of like Texas, for example, right? And so this is what I'm looking at for getting Elixir onto the AI flywheel. Not that we're like we're benefiting from it too, right? You know, so but we can be more deeply involved. So a better LLM ecosystem results in better Elixir code gen. Better Elixir code gen results in better Elixir software, and that can feed back into a better LLM ecosystem. That's what I got.